Okay, so continuing on from where the previous video inadvertently shut down, we are on to the last of our indices laws. So that is, what does a to the power of a half mean? Or what does anything to the power of a half mean? Well, something to the power of a half is basically the square root of it, okay? So 4 to the power of a half would be the square root of 4, and the square root of 4 is 2. So a to the power of a half equals root a is how it would be written in your book. One other thing to remember when we're doing this, don't forget your orders of operations, BOMDAS. Okay, so BOMDAS or BIMDAS. The O stands for orders, which means powers or indices. The I stands for indices. Okay, so indices, powers, surds, square roots, these things all appear in a sum after you've simplified your brackets, so before you do any multiplication, division, addition, or subtraction. So let's look at a couple of examples. I'm going to do a few examples now from the sections. I think it's exercise 16.1 in your book. I don't know the page number for you because you've got an older edition to me, but it's exercise 16.1, chapter numbers 2 or whatever, indices in standard form. Okay, so question 1, part 1. We're asked to write each of these in their index form. And by the way, when something's written as a power, that is its index form. So when we say index form, we mean as a power. So we have here is 2 by 2 by 2. They don't want us to find out what's 2 times 2 times 2. Okay, that's not what they're asking. I just write it in index form. So they want to write it as 2 to the power of something. Well, to the power of what? Very simply, how many 2's have I got here? I have 3 of them. So it's going to be 2 to the power of 3. Let's look at another example. Part 5, k times k times k times k. So it's going to be k to the power of what? 1, 2, 3, 4. K to the power of 4. Question 2. Write each of these as a single number without a power. And that would be 10 by 10 by 10. So this time, if the same is a single number, not as an index form, they want you to work it out. And this is, by the way, 2 part 4. So 10 by 10 is 100 by 10 would be 1,000. Okay? Question 3. Write each of the following as a single number to a power. So they haven't used the term index form, but they're saying to a power, meaning they want it in index form. Alright, so let's look at this. 3 to the power of 2 times 3 to the power of 5. Well, if we think back to our multiplication law, when I'm multiplying two of the same number with different powers, I add my powers. So it's the same number, 3, multiplied, so I add the powers. So 3 to the power of 2 times 3 to the power of 5 is the same as 3 to the power of 2 plus 5, or 3 to the power of 7. Alright? Question 4. This one you just need a bit of practice, folks. I'm sorry, there's no really good way to do this. You just need to try and figure it out, okay? Now, let's look at the first one. 2 to the power of something equals 8. Okay, well, 2 to the power of 1 is just 2. 2 to the power of 2 is 2 by 2, which is 4. 2 to the power of 3 is 2 by 2 by 2, which is 2 by 2 is 4 by 2 is 8. So it's 2 to the power of 3 is equal to 8. Let's look at another example. Question 4, part 6. 5 to the power of something is equal to 125. 5 to the power of 1 is equal to 5. 5 to the power of 2 is 5 by 5. But any number that doesn't have a power is basically to the power of 1. I can't remember if I said that or not, but I'm saying it now. Any number without a power is just to the power of 1. So 5 by 5 is 25. 5 by 3. 5 by 5 is 25. By 5 is, oh look, 125. So by sheer coincidence, the same answer as the previous one, the answer was to the power of 3. Alright, question 5 is the exact same as question 3, except for one difference. Now our numbers are different. So maybe it's not the same. 3 by 2 to the power of 2. So you might go, oh, sorry, just add the powers. No, we don't, because it's 3 by 2. These are different numbers. So that's going to be 3 by 2 by 2. Now, by the way, you could just use your calculator. Go 2 squared is 4. Remember I said BOMDAS, BIMDAS. powers, then multiply. So that would be 2 by 2 is 4, by 3 is 12. Let's look at another one. 2 by 2 by 3 by 3. Well, 2 by 2 is 4, and 3 by 3 is 9, so that's 36. All right? So let's look at now question 6. Evaluate each of the following. 6 part 1, minus 2 squared. Now, folks, sometimes people get messed up with these powers when it comes to their signs. That's simply because you have forgotten first year maths, rules for integers. Minus multiplied by minus is always a plus. So what's that saying here? Minus 2 squared. It's a minus 2 multiplied by minus 2. Minus 2 times itself twice. Well, 2 by 2 is 4, and a minus by minus is a plus. So this is going to be 4. All right? Now let's look at the next example. Minus 3 cubed. That's minus 3 by itself 3 times. So minus 3 by minus 3. 3 by 3 is 9. Minus by a minus is a plus. So that's plus 9. But we still have another minus 3 here that we have to solve for. Okay? 9 by 3 is 27. But we now have a plus multiplied by a negative value. Plus by minus is a minus. So it's minus 27. And then this illustrates an important little trick to remember when it comes to these powers. Whenever you have a minus number to a power, okay? A quick way to do this would be just ignore the sign and just do the sum as normal. Then look at the power. If the power is an even number, like this, 2 or 4 or 6, whatever, okay? If it's an even number, your answer will always be positive. If the power was an odd number, then your answer is always negative. So I could have just gone, well, 3 cubed is 27, but because it's to the power of 3, 3 is an odd number, and it was a minus 3 cubed, it becomes minus 27. All right? So that's it for now. Your homework for tonight is going to be to finish up to question 6 on exercise 16.1. Thanks, everybody. Do not be wrecking people's heads. Try and help out where you can at home, and remember to wash your hands.